So in this video, we're going to look at sequences for the first time. So what is a sequence? Well, as it says in this top box here, a sequence is an ordered list of numbers defined by a rule. Right, so in order to understand sequences, we're going to need to have some new notation. So let's start with a really simple, easy sequence. 2, 4, 6, 8, 10, and we'll go on and on and on. Look, okay, I can't think of anything easier to understand than that. So this 2 is the first number in the list. So we're going to call this U with a little subscript 1. 8 is the fourth number in the list. So we're going to call this one, look, U4. All right, so that's how we name the numbers in the list. A general term, right? Okay, maybe there's some number over here, look, right? Well, we don't know which value it is. We're going to call it UN. And that is term number N, right? So N is going to be the term number. So this one here, look, is when N is 1. This 8 is when N is 4 because it's the fourth number in the list. So that's how our sequence notation is going to work. Now, you'll notice that these ones are going up by the same amount each time. And we'll talk about this in just a moment, but that means this is an arithmetic sequence. And that difference between the terms is known as D. So we're going to say that D is equal to 2 in this particular case. So let's just focus in on that arithmetic sequence. Well, again, and it's defined to be a sequence in which each term differs from the previous one by the same fixed number. And as I said before, that's known as D, the common difference, right? And so for any term, if we take away the previous term, we are always going to have this thing D, right? This difference. Okay, so let's think about these and try and find some just play around with it to get some better understanding. So let's take a look at this example here. Look, we've got a formula. Look, so it's telling us that UN, that general term, right, is 3 multiplied by n minus 2. So if I wanted the first term, like in part A, what I need to do, U1 is going to be 3 times 1 minus 2. Well, that's going to be 1. If I wanted for part B, U5, well, U5, the fifth term, is going to be 3 times 5 minus 2. Well, 3 times 5 is 15. Take away 2. That fifth term is going to be 13. If I want the 27th term, so for part C, U27, I'm going to need to do 3 multiplied by 27 minus 2. Well, 3 times 27 is 81, minus 2 is 79. So there are our solutions. Hopefully, you're getting a good idea of how this is working. So let's think now about this general idea of an arithmetic sequence, and we'll see if we can consider and work out a formula. So let's imagine we've got that first term, U1. Well, another way of writing U2, the second term, would be to start off with the first term, but add the common difference. The third term, well, that would be the second term plus another common difference, whatever that may be, because it's arithmetic, it's going up by the same amount each time. So it's going to be U1 plus 2D. The fourth term, well, that's going to have another D added on, so it'll be U1 plus 3D, and so on and so on and so on. So that's one way you could think about an arithmetic sequence. Now, can we generalize this, right? Can we generalize this to work out the formula for any term? So let's call that UN, right? So we're looking for the nth term. Maybe it's 5, maybe it's 10, maybe it's 100, right? Whatever we're looking for. Well, we always have a U1. In every one of these, there's always a U1. And we always have some multiplication of the common difference. But you notice if I'm looking for the fourth term, there was a 3 there. If I was looking for the third term, there was a 2 there. So it's always going to be n take away 1 multiplied by the common difference, right? And that is our formula. Now, there's one thing to write down. Is that, okay, that is our general formula to find out the outcome for any particular term number, right? Okay, so let's have one quick easy example and then we'll look at some further applications of this in the next video. So, first of all, we've got a sequence 2, 9, 16, 23, 30. First thing we've got to do is show that the sequence is arithmetic. Well, we can do that very easily because we just have to show that each term goes up by the same amount each time. So, for example, we could take the second term minus the first term. Well, that's 7. We could take the third term minus the second term. Well, that's 7. The fourth term minus the third term. Well, that's still 7. And that fifth term minus the fourth term. Yep, that's still 7 as well. So that is how we're going to do this. We'll say hence arithmetic. Okay, let's move on to part B. So find the formula for the general term. Right, so let's just make sure we've got it clear in our minds. What we just derived was this general formula, and you get this in your exam formula booklet, so you don't have to remember it. There we go. We've derived this. This is what we start with. Well, let's see if we can work out U1 and D. So U1 is very easy because it's given to us in the question. U1 is just going to be 2, the first term. Look, there it is. And we've just proved that it's arithmetic by showing the differences are 7. So D equals 7. So all we need to do now to show, to find this formula is to put these values into that general formula. So UN is equal to 2 plus n minus 1 times 7. Let's see if we can simplify this a little bit. So we're going to have, let's multiply out that bracket. We'll have 7n minus 7. So maybe our final answer for this, UN equals negative 5 plus 7n. And that's probably our easiest way of writing that particular formula. Okay, let's carry on. Let's see what the next part of the question is. So part C is to then find the 100th term of the sequence. Let's change color at this point. Okay, so the 100th term, well, that's going to be when n is 100. So all we have to do then is to find U100 is to pop that 100 into our formula. Minus 5 plus 7 times 100 is going to be our 100th term. Well, that's going to be 695, and we are done. Okay, final part of this. So we've got to work out, is 828 part of our sequence, and is 2341 part of our sequence? So let's start with the 828. Well, if it is, we'll be able to work out what term number it was. So let's just say that UN is 828 and see if we can get a whole number value of n. So if, for example, if we found out it was 12, we know that 828 is the 12th term. Right, so we'll set our formula equal to this number. So let's now add 5 to both sides. So we're going to have 833 equals 7n. Now we can divide by 7, and if we do that on a calculator, we're going to get n is 119. Yes, this is a whole number. Yes, 828 is in the list. Okay, let's now try part 2. So for part 2, we had to see if 2,341 was in our sequence, 2,341. So we're going to set this equal to UN, and we're going to put this into our formula. So our formula says that 2341 is equal to minus 5 plus 7n. Well, just like last time, we'll add 5 to both sides. 2346 is equal to 7n. Now, if we divide that through by 7, we're going to get n equal to 335 and a 7th. Now, this can't work. There's no way we can have the 335th and a 7th term in a list. So no, this 2341 is not in our list, or in our sequence, I should say. Okay, so that one is a no. Okay, so hopefully this video has helped you to understand a little bit about the notation behind sequences. It's explained to you what an arithmetic sequence is. We've derived that formula, and we've given you a quick example of how you can use that